Hello, ladies and gentlemen. Welcome to Math 10C, Chapter 1, Lesson 1, Imperial Measurements of Length. By the end of this lesson, I expect you to be able to first provide reference for linear measurements, including millimeter, centimeter, meter, kilometer, inch, foot, yard, and mile, and explain the choices. And estimate a linear measure using a reference and explain the process used. Now, before we get into that, there's some review, just because it's been a while for some of you guys. So first thing is rounding. Now, we call the placeholder names: thousands, hundreds, tens, ones, tenths, hundreds, thousandths. All right? So if I asked you to round some numbers to the nearest tenth, that's the 1 decimal place. So these numbers, the 172.4, 39 is closer to 40 than it is to 30. 36.049, that's 36.0, because 0.4 is closer to 0 than it is to 10. And 6.33333 becomes 6.0. Okay? Now you have to be able to do this because Mr. Calculator will spit out not ridiculous, but big numbers and lots of numbers, and you have to be able to go, no, that's not correct. Now, notice they said to the nearest tenth. What if I said to the nearest 10? The nearest tens. Okay. So 172.3945 becomes 170. 36, the tens, 36 rounds up to 40. And 6, is it closer to 10 or closer to 0? It's closer to 10, so this would round up to 10. Okay, be careful, tens and tenths. Okay, now, round to the nearest hundredth and the nearest thousandth. So I'm going to pause the recording. I want you guys to round these to the nearest hundredth, the nearest thousandth. We'll come back and compare answers. Okay? Okay, welcome back. The nearest hundredth is 2 decimal places, so that's 5.68 and 0.02. 17 would round up to 20. Or sorry, yes, 17 would round up to 20. It's closer to 20 than 10. To the nearest thousandth is 3 decimal places, so 5.6834 rounds off to 5.683. 0.01704 rounds off to 0.017. Okay, thousandths. Now, next thing you should remember is scientific notation. Like I said, you should remember this, just hitting high points. L times 10 to the D, where L is a number greater than or equal to 1 and less than 10. And D is a whole number integer, can be positive or negative. So remember these. Standard versus scientific notation: 125,000 is 1.25 times 10 to the 5. 0.000254 is 2.54 times 10 to the minus 4. Okay? Now, the speed of light is 300 million meters a second. What is this value rounded to the nearest tenth? So, in scientific notation, I'm sorry. So if I put this in scientific notation, the decimals here, 1, 2, 3, 4, 5, 6, 7, 8. 3.000000 times 10 to the 8 meters per second. But I said rounding it to the nearest tenth, that's 1 decimal place. So that becomes 3.0 times 10 to the 8 meters per second. And notice with the scientific notation, there's a lot fewer zeros, it's a lot easier to write. The radius of the Earth is 6.37 times 10 to the 6 meters. Express this value in standard notation. 1, 2, 3, 4, 6. So that's 6370000 meters. Notice, once again, the scientific notation is a lot easier to write out. Okay? That's shorter. Oh, and the scientific notation tells you the correct number of significant digits. Now, cheating shortcut. Look for the EE button. You'll have to use the second function key, hit the EE, but it's right here above the comma. So you press the second, then comma, which has EE above it, to bring up the exponent value, EE. And remember, the calculator doesn't care about significant digits. It's up to you to round off the answer. So, grab the calculator, turn it on. Oh, yeah, booby head stuff. No. All right. Over here, yes, booby head. All right, be like that when people are watching stuff. Okay, whatever. Trying to impress people with technology. Whatever you do, technology doesn't work. There we go. Whatever. So, as I said, press the second button, the comma, EE, and there it is. Now, sometimes on some calculators it's E, some calculators it's EE. So if I go 1.2 e to the 6, that's scientific notation shortcut for 1.2 times 10 to the 6, or 1,200,000. 6.37 exponent to the 6, 637, 6,370,000. Yes, we just saw the number back here. So that's how you go from scientific notation to standard notation on the calculator. Now, what I want you guys to be able to do is evaluate and round as indicated. So, 4.58 times 10 to the 4, 4.58 exponent to the 4, times 1.21 exponent to the negative 3, 55.418. Now, notice I didn't need brackets there, and I didn't go times 10 to the power of. This is a much quicker way to do it, and it's something I expect you to be able to know and use. Now here, I also said round to the nearest hundredth, so that's 2 decimal places, so this is 55.42. Okay? Now, I'm going to pause the recording. I want you to do the second one, 1.3 e to the 5 divided by 5.033 e to the 3, and tell me the answer to the nearest tenth. Come back and we'll compare answers. All right? All right, so welcome back. 1.30 exponent to the 5 divided by 5.033 exponent to the 3 is 25.82. 952513, but as I said, to the nearest tenth, it's 1 decimal place, 25.8. Note there, no brackets, note to the power of. Very quick and easy way to do it, and it's the way I want you to do it. And trust me, when you get to physics and higher maths, you want to be able to do it this way. Now, I'm going to pause the recording. I'm going to ask you guys to do this one. Now, I suppose I should be nice. Order of operations, you really have to put this in brackets or it's going to confuse Mr. Computer. And you should put this divisor in brackets also. Okay? So I'd start off, bracket, 5.311, exponent to the negative 5, plus 1.3 exponent to the negative 4, close bracket, divided by bracket, 7.033 exponent to the negative 2, times 8.95 exponent to 4. 2.90903 times 10 to the minus 8. Now, that would be, sorry, I think I can move over here so I'm on the right. That is 0.1234567. Then I go 2909. Now, the nearest 10 thousandths, that's tens, hundreds, thousands, 10 thousandths. That's 0.0000. Too small a number. Okay? So we do all these calculations, but our number is too small to count. Oh, I'm going to pause the recording now. If you have any problems with this, watch the video again, shoot me an email, otherwise we'll continue.